the Frobenius method, no, still under the power series. A singular point x sub o is said to be a regular singular point of a second order differential equation in the following form. If the functions x minus x sub o multiplied by p of x and then the square of x minus x sub o multiplied by q of x are both analytic at x sub o. Otherwise, the point is an irregular point. Determine all singular points and identify which of these points are regular points. So you're given second order differential equation. This one is homogeneous. We transform the equation into the standard form. Okay, by multiplying the whole equation by x times the square of x squared minus 9 so that the coefficient of y double prime will be equal to 1. Okay, so we have the following, and we'll take this as your p of x, and this one will be q of x. Okay, so this can be simplified. Okay, x squared minus 9 is x minus 3 times x plus 3. So simplifying, we have 1 over x times x minus 3 quantity squared times x plus 3. For q of x, we have 5 over x times the square of x minus 3 and the square of x plus 3. Hence, we see that 0, 3, and negative 3 are singular points. Now we check using the definition if these points are regular points. Okay, we start with x equals 0. Okay, so applying this definition, okay, this is your p of x multiplied by x since x sub o is 0. And then, okay, so x will cancel out to give you 1 over x minus 3 quantity squared x plus 3. So, the resulting equation is defined at x equals 0. So, is analytic at x equals 0. And for the second condition, okay, we multiply q of x by the square. Okay, so we have x squared here multiplied by q of x. So x here will cancel out, so that will give you 5x over the square of x minus 3 and the square of x plus 3. So in this case, x equals 0, or the function is also defined at x equals 0. So since both functions are defined at x equals 0, then x equals 0 must be a regular singular point. Now, by definition, we can see that x equals negative 3 is also a regular point, but x equals 3 is an irregular point. Now, if x equals 0 is a regular singular point of the differential equation, then the said equation has at least one solution of the following form. So this is our original power series. No, when x, for example, when x equals 0 is an ordinary point. In the Frobenius method, we multiply x minus x sub o raised to the power of r. But your x sub o here is a regular singular point. And then simplifying, we get this power series solution, where the number r is a constant need to be determined from the initial equation. The initial equation is quadratic in this case if we have a second order differential equation. So that is the equation derived from the identity property. And the series solution is valid in an interval from 0 to k for some real number k. So this theorem tells us that even if x equals 0 is a singular point, then it has a power series solution near x equals 0 if it is a regular singular point.